The goal of this project is to find the optimal renewable energy source in order to meet the government's interests of lowering carbon emissions, reducing power prices in South Australia, and also to have the state be completely energy independent by 2042. The requirements of this project is to seamlessly switch over to renewable energy sources where the consumers will not be negatively impacted by the changes when they happen. Furthermore, the new renewable energy system must be compatible with the current electrical energy grid, which means that the system must meet certain technical requirements for grid stability, and it must also be able to withstand disturbances to the power system. The scope of the project will be to purely focus on existing concepts and technologies that can be tried and tested in South Australia. Additionally, the project will assume that the already installed power grid lines will be used, and hence only the electric generation hubs will be replaced. The 5 solutions that we will be putting forwards are wind, hydro, nuclear, wave energy, and solar concentrated farms. Wind energy is produced by the help of wind turbines. Power is generated when wind flows across the rotor blades, causing the rotors to spin, which are connected to the generator, and this therefore produces electricity. Hydroelectric energy is a form of renewable energy that uses the power of moving water to generate electricity. The energy developed by the movement of water depends on the mass of the water flow and the height and elevation, which is also known as the head from one point to another. Wave energy is obtained with the help of nanogenerators. The design involves a spring-like coil inside a cylinder, and current is generated when the wave pushes the cylinder back and forth. The separate parts of the spiral come together, producing significant current. Solar concentrated farms harvest renewable energy from the sun with the help of solar photovoltaic technology from the fields of solar PV panels. To assess the renewable energy design options, a performance criteria will be set up. The elements of the performance criteria are setup cost, maintenance cost, environmental impact, power output, power reliability, lifespan, and safety. To begin with, the setup cost will be looked at. To assess the setup cost, we are setting up a benchmark, which is the standard gas energy power plant in Australia, and the average setup cost is 87 cents per watt. Therefore, the design that costs significantly lower than a gas energy power plant of a similar magnitude will score higher. The weightage of this criteria is 15%, as it is viewed that the cost is of significant concern. The next criteria is maintenance cost. To evaluate the maintenance cost of the design, we'll be using the maintenance cost of a gas energy station in Australia as a benchmark. Our references have found that it costs 9 cents per watt to maintain a gas energy power station, and the weightage of the criteria will be 5%. The third performance criteria will be environmental impact. Renewable energy sources are well known for their minimalistic impact on the atmosphere, for example, reduced to no greenhouse gases. But land scarring can occur when setting up power stations that operate as renewable energy sources. This could lead to the destruction of vegetation in certain areas, worse physical appearance of natural view, and ultimately the destruction of wildlife. The renewable power stations will be compared to gas power plants, and therefore a score will be provided. We also view environmental impact quite highly, so therefore we weight it at 15%. The next performance criteria is power reliability. With the current systems that we have here in South Australia, there are little to no power outages. Obviously, we want an entire renewable grid with no power outages. Because renewables can be influenced during certain times of the year, systems need to be considered for the super hot summer months and the relatively cloudy and stormy winter periods. However, during spring and autumn, renewables are very reliable, with 107.3% of power demands on Sunday the 4th of April in 2020 were supplied by renewables. And the next performance criteria is lifespan. Again, we'll be comparing the lifespan of a gas power plant to our solutions that we can put forth. And on average, the lifespan of a gas power plant is 25 to 30 years. The final performance criteria is safety. There are 2 aspects of safety that will be considered. Firstly, there is the safety of the plant workers, and secondly, there is the safety of the population. Both regular and irregular events will be considered, and they will be compared against gas power plants.
Based on our performance criteria, we evaluate and find out that our optimal solution is the wave energy production method. Therefore, we will now discuss on its infrastructure, its environmental and sociological concerns, as well as its legal and ethical concerns. Under its infrastructure, the turboelectric nanogenerator is spherical in shape, which is based on the coupling of spring-assisted structure and swing structure combined with the charge excitation circuit. The spherical nanogenerator generates current by transforming low frequency water wave vibrations to high frequency motions, which elevates the frequencies of electrical outputs. Since the energy from nanogenerators can be stored in lithium ion based batteries, therefore the big Tesla battery in South Australia, which is capable of storing up to approximately 150 megawatts, can be used to store excess energy produced by the nanogenerators. The transmission system should ideally have aerial power lines which are connected from the nanogenerators on the seashore to the onshore transformers in order to convert the voltage produced from the nanogenerators to standard 275 kilovolts. Since a very high amount of voltage is being dealt with, therefore a suitable circuit breaker system is needed. The preferable circuit breaker for this transformer would be the circuit breaker made by GE in view of the fact that it can support voltage ratings of up to 800 kilovolts. Under monitoring and communication, a sensible monitoring and control plan would be setting up an onshore communications tower that is connected to wireless sensors mounted on the wave generators. These sensors would send live data to the tower where either a computer system can monitor the fluctuations in energy generation and whether or not there is any malfunction. Monitoring systems will need to use an SCADA software to correctly set up wireless sensors that transmit their data, as SCADA is the standard renowned system category for wireless sensor communication. Under environmental, the best way to consider environmental and sociological impacts is to consider the 3 Ps of the triple bottom line. The 3 Ps are profit, people, and planet. The first aspect is profit, which is from the view of the government, as the government will be the owners of the power station in their best interest. The cost should be kept low in order to be favorable candidates for presidency. Plus, the business owners and general population will benefit from cheaper power prices because it will lower their cost of living. Secondly, that the employees will have their personal needs met in regard to safety and fair compensation. To expand on that, contracts will be handed to local businesses, which will gain further the careers of the general South Australian Republic. Finally, the last P is the planet. It is most important to consider the delicate ecosystem that is the South Australian coast. Serious measures will be put in place to make sure that no waste is released into the ocean and the modules are safely disposed of at the end of their life. The business model of our solution contains the list of all the expenditures and we have categorized them according to their priorities. We have allocated the cost required for the whole project. The most frightening risk that we can think of is a tsunami. If a tsunami was to ever happen near the power plant, this would damage and wipe out everything that had been built. Setup cost for the station is approximately 175 million AUD. Setup cost for the transmission is approximately 25 million Australian dollars. The maintenance cost is roughly about 6% of the initial capital. Now we talk about the safety of this solution. Safety is the top priority when it comes to working at a working site that is risky, such as a power plant. A power grid is considered safe if all parameters like voltage and frequency are bounded within the predetermined limit and also being monitored. A safe power grid must operate under the requirements of national electricity rules and AEMC's reliability panel. The rules are as follows. Control the operation of wholesale electricity market. The market arrangements for commercial exchange of electricity from the electricity producers through to the electricity retailers. Controlling the economic regulation of services provided by monopoly transmission and distribution networks. Thirdly, govern the way in which the Australian energy market operator manages power system security. And lastly, apply to those states and territories that are electrically connected, that being Queensland, NSW, ACT, Victoria, South Australia, and Tasmania, collectively referred to as the National Electricity Market. Work health and safety instructions must be followed by everyone on premise, whether employees, employers, visitors, or customers, as it can prevent unwanted accidents from happening. Under Australian WHS/OHS legislation, businesses are legally obliged to provide safe work premises, assess risks and put in place appropriate measures for controlling them, ensure safe use and handling of goods and substances, provide and maintain safe machinery and materials, assess workplace layout and provide safe systems of work, provide a suitable working environment and facilities, have insurance and workers' compensation insurance for your employees. Having SCADA systems used to monitor and control the power output produced at power at a power grid makes it easy for everyone to keep track of the data and safer for everyone instead of having to go to the power grid themselves. Despite all the precautions taken, everyone had to be extra careful when being present at the power grid. For our project, we will have legal and ethical concerns to be considered, as they are one of the most important considerations for our project. Under legal, a compound must be built in order for the PENG system to be established. Legal documentation or agreement by government is required to own a space to prevent conflict between the previous occupants. A patent must be legally enacted to preserve the company's name, integrity, and ideas or information from being stolen. Agreement between the employer and the employees regarding safety to ensure safety and a fair environment for everyone. Staff insurance policies must be registered if ever bad scenarios were to happen. Company insurance must be guaranteed to recover from such property damage. The company must be aware of legal rights entitled to the indigenous people and must always consult them in order to occupy specific free land spaces. For our ethical concerns, staff members must act respectably and fairly to each other. Employees must not terrorize the lives of each other, or else they will be penalized through means of such as suspension or a fine, maybe even a forced resignation. Employees are forbidden to steal or cause loss of data information. Failure to abide so might result in the company to become vulnerable to the public, as the company's valuable secrets may be exposed. As the optimum solution chosen was the wave energy method, the power generation will be near South Australian coasts, which could be occupied by the indigenous people. Therefore, consultation with the elders are required to prevent breach in the indigenous people's ethics. All those mentioned ethical concerns must be agreed upon contract hiring, meaning any engineers that are employed by the company are supposed to agree to these terms and conditions of the contract and are expected to follow the standard Code of Ethics Engineers Australia. Upon conclusion, once the project is successfully implemented, South Australia will become an environmentally friendly energy provider, which would thus conserve the fauna and flora of this beautiful state. Most importantly, electricity prices will also drop as renewable energy will be more often used. Thank you for your time.